Hi, I'm Mike at 21 Degrees. I'm going to talk you through the Mvhr display that you're looking at. Starting with the obvious position point, the Mvhr unit itself. We typically use Passive House certified units because of the quality they come with. They have a built-in frost protection, they have constant volume fans, and they have a built-in summer bypass. Not all Mvhr units have that, but all Passive House certified units do. So that's what we use all the time. Although we're not tied to any manufacturer, we choose the right product, the right unit for the project that we're looking at. We also make sure the unit's not using any more than 70% of its capacity, because you don't want a mechanical item running at 100% capacity all the time. As well as being a heat recovery unit, this is effectively also constantly a dehumidifier, constantly. So you get condensation. So there's a condensate drain that has to run away to your nearest drain. So the unit always needs to be off the floor. It can be wall mounted, but you need at least 200 mil off the floor to take the condensate drain out. Inside there, we have the heat exchanger itself. If you think of a chessboard, white is supplying, black is extracting, there's a membrane sitting between the two, and only heat crosses through the membrane. The physics of our world is heat always crosses the cold. So when we have -5 here, coming in, supplying, and 21 degrees going out, extracting, up to 91% of that heat crosses through the membrane, and -5 enters the building at 17 to 19 degrees, not -5. So your heat has just been dramatically reduced. It's also passed through filters, so pollen and diesel particulates and other items are being extracted. So you've got fresh, clean, pre-warmed air being supplied to your living rooms, dining rooms, bathrooms and studies. Flip it on its head. On a summer's day, 35 degrees outside, that day of the year, 35 degrees coming in, 21 degrees going out. So up to 91% of the differential crosses to the cooler 21 degrees, and the 35 degrees enters the building at 23 to 25 degrees. So now dramatically reducing the need to cool. So the only really maintenance you need to do on an Mvhr unit is change the filters. It's quite simple. Pull the cover down, release that, place it there, and the filter, you pull it out. It's a paper filter. So you pull it out, dispose of it, put a fresh, clean filter in, pop that back on, close that back up, and you're good for 6 months. Just talking through these now. This is the connection to the outside. This is the supply and the extract connected to the outside of the building, to the outside. So we always insulate these to stop any possible cold bridging of air coming through if this was metal, and to stop any condensation inside. The two on this side, the metal ones, these are primary attenuation. These stop the sound of the fans. Inside this unit, there's 2 constant fans running. These kill the sound of the fans so that noise cannot travel through the ducting. They aren't always this big. They are sized to suit the project that we're designing to and the airflow that we've got. Right, look at the ducting now. We prefer to use this type of ducting. It's rigid spiral-bound galvanised steel. We can use the other ducting if we have to, which is a plastic radial system, but this is our preference. So if we start down here where the attenuator is attached, we start at 160 mil diameter. As we come off the top of the attenuator, we're down to 125, and we get down to 100 mil diameter as fast as we can, and the majority of the ducting running through the building will be 100 mil diameter. The next part you can see are these boxes. These again are attenuators. We've got a pipe of air running through the building so sound could travel. So in all the supply rooms, so your bedrooms, living rooms, dining rooms, studies, immediately before the air valve, we put the attenuator. This does, the key job of this is to stop sound travelling back out of the room so it can't go into other rooms. So it stops sound travelling from room to room. It also has a little bit of input at controlling the sound level there. We now get to the supply air valves. We prefer to use air valves that use the Coanda effect. The air clings to the ceiling and distributes around the perimeter of the room so you can't feel it. We also make sure that the sound at the air valve is below 25 decibels of sound. We human beings start to hear at 25 decibels of sound, so we guarantee that the sound coming in to the building in all your living spaces will be inaudible below 25 decibels of sound. So this is one type of supply air valve. It's flatter. This is like a designer one. It costs a little bit more. That's a standard one, which is more concave, but they both do the same job. They both use a commander effect. This one just looks a bit neater, but costs a bit more. So they are supply. They go to your living rooms, bedrooms, dining rooms, studies. Then we have extract. So your bathrooms, toilets, shower areas will have an extract like that. Your kitchen extract is like that. It's got a fleece filter in it. In the kitchen, we recommend you use a recirculating cooker hood. That's recirculating. You want to capture the grease, but don't throw the heat out the building. And then this as a fleece filter that again you change twice a year. That'll catch any of the remaining grease that your recirculated hood hasn't picked up. The key thing to get over to you, the Mvhr unit is in some very clever physics, but it's the ducting that delivers everything. To have the supply into your living rooms and bedrooms that you can't hear, because it's below 25 decibels of sound, that you can't feel, because it's travelling less than 1 metre a second, so you can't feel it, and then we're using the commander effect. It's not delivered by the unit, it's delivered by the ducting. And the ducting design on Mvhr is the most crucial part. And that's what we've got over 16 years experience with, of delivering efficient, silent, filtered, well-ventilated buildings. The internal humidity stays at 40 to 60%, which is a sweet spot for us human beings. And the nasties like bacteria, virus, and dust mites don't like it. They like it to be lower than 40% or higher than 60%. So you're getting fresh filtered air, perfect humidity, and the heat recovery. The only other service we offer on top of that is you've got the maintenance of changing filters. We suggest probably every 4 or 5 years to have the unit serviced. So we offer to, we'll come and do that, or another professional could do it. They would take the heat recovery unit out, clean it, and check all the air valves that they are set to where they should be. So changing filters twice a year, service once every 4 or 5 years. So if you scan the barcode, you can get more information from us or ask us to get in touch with you to discuss your particular project.